Hello, I hope I'm audible to you guys. Can you please confirm?
Yes, you're audible.
Okay.
Yes, ma'am, you're audible.
We'll wait for some time to let other people join and then we'll start the session.
Okay.
Hello everyone. I hope you all can see me and hear me properly. Hello.
Yes, yes.
Yes, ma'am.
Okay. Thank you for joining. So today is the first day session for this course, Drug Delivery Principles and Engineering. And so there was some mistake in our part that we have three TAs for this course, and all of us have scheduled the TA session at the same time. That's why it's divided. But from next week onwards, it will be on different timings or different days. Okay, so we'll start for today's session. Did you guys go through the lectures for the first week?
Yes, ma'am.
Okay. Did you had any doubts or anything you want to discuss on that? I'll try to share my screen. Uh, Let me know if you guys can see my screen. Can you see it?
Yes, we can.
Okay. Okay, so basically, in the first week, these were the topics that were covered. First, an introduction to drug delivery, which is basically administration of the appropriate amount of drug through different routes or vehicles, such as microparticles, nanoparticles, that will be discussed in more detail in the upcoming lectures. And then pharmacokinetics, which is uh, which helps in basically designing the drug dosing regimens based on how much you need to administer, what is if the drug is achieving its therapeutic value or not. All those things you can study with the pharmacokinetics. And several factors that affects the pharmacokinetics, such as the partition coefficient, the solubility, ionization, those things were also discussed. Next, prodrugs. So prodrugs are basically premature drugs, you can say, or drugs that are modified to not be active, and after introduction into the body or action of certain enzymes or other reaction, the actual active drug is released from the prodrug formulation. So a bit of prodrug was also discussed, and then there was introduction to polymers, their synthesis, step reaction, chain reaction, and polymers properties, the melting properties, the glass transition temperatures, as well as the amorphous, crystalline, all these properties and the molecular weight of the polymers, all those things were discussed. So please let me know if you had any doubts or questions in these topics, and then we can start the previous year assignment that was based on these topics. If not, just let me know, and then we'll continue discussing the
Ma'am,
this. Yes.
uh, can you explain what is like volume of drug in that it was said in lectures that like for suppose 70 kg of like suppose 70 kg human is there and total volume of body water is like 50 to 60 liters. So how can we relate these two things? Like it is also given means the example is given like warfarin apparent volume of distribution is 8 liters. So
Right.
a high degree of plasma protein binding. So like these things I'm not getting. Like there were some examples.
Right. So the volume of distribution is basically the amount of drug in the body by total concentration in the plasma. Uh, Let me just quickly allow someone is waiting to join. Okay. So, yeah, as I was saying, the volume of distribution. So, you need not be very accurate with the volumes. As you followed in the example, they are taking 30 liters or 50 liters for water and some other volume for fat. So, if you look at some If you look up in the internet as well, you'll find what is the approximate volume for the blood, the water, the fat, all those things. So that will help you determine whether your drug amount, based on those volumes, you can say whether the drug amount is released in the body fat, in the aqueous, or in the blood. So it's just making an assumption. If you are asked to solve a numerical question, you can just simply assume either 30 liter or 50 liter. If you're taking that volume for water, just assuming that volume, continue with your solving your equation and you'll be fine with that. But it's a range of volume. You can't just pick a particular volume with that.
Okay, ma'am. And ma'am, suppose if like it is given that for ethanol the apparent volume distribution is 30 liters, so
Yeah,
compared to blood it is like more. So how so will it be distributed in whole body or just in
more
water
water,
only?
more water. That's why I told you to just look up some volumes. I mean, just keep in mind that what is the volume for volume distribution of water in your body for an approximate 70 kg or 50 kg human. Just look up these volumes, and based on that volume you can just simply correlate. If 30 liters it's saying blood volume, I mean 30 liters distribution, and you see 30 to 50 liters is for water, then you can quickly assume that all of this is going into the aqueous phase in the body.
Okay, ma'am.
Does that
Thank
make
you.
sense? Yeah. Okay. Anything else? Does anybody else has any other questions from these topics covered in the first week? Or shall we start the...
I have, ma'am, I have one doubt from that assignment question.
Okay. I think your due date is August 7th, I guess. Am I correct? Hello?
August.
Yeah, yeah,
No,
ma'am.
ma'am.
August 7th.
Is it? So I can only give you a hint or explain the topic, but I can't help you on solving that particular assignment. You can still ask away, and maybe next week when we follow up the session, I can solve that equation, or sorry, the question, if you still have doubt. Which question you want, by the way?
Ma'am, means it is like second order reaction that there are two options, but I feel that there is only one option.
I see. So I would suggest sometime this happens that there are some wrong options as well. So you just click on whatever you feel the correct option is, and then you can mail the coordinators or other NPTEL team saying that this is the correct answer. Can you please confirm with the answers? You can always reach out to them about these questions. Sometimes there is some mistakes, so if you feel like none of the options are correct for that question, also you can reach out to them. Don't worry about it now. And if they have some other options as correct, but all of you feel like that's not the correct answer, that can also be, you know, readjusted in your scores. So you just try your best now, and then um, we'll see what is the correct answer after the submission of your assignment.
Okay, ma'am.
Okay. Any more questions? Okay, then I'll start with the first question from the previous assignment. So these are some of the assignment questions from the previous year. This was the first question. Which two statements are true for pharmacokinetics? I'll give you some time to read through the options and you guys can let me know what you think the correct answer and then we can discuss. Yes, so there are two statements which are true for pharmacokinetics among these options. I'll read out the options if that helps. Pharmacokinetic studies help in determining the dosage regimens. It helps us, option 2 is it helps us understand the drug receptor interaction at the tissue level. Third option is its studies are used to identify new drug targets. Fourth, its pharmacokinetic studies how drugs are absorbed or metabolized throughout the body. Fifth, it studies how diseases spread in a geographical region. Sixth is it studies how the mutations in genes responsible for diseases. And seventh is it studies how drug dissolves in water and diffuses in air. Is anyone ready to answer? Which of the two statements you think are true for pharmacokinetics?
The fourth one
Okay.
and the second one.
Okay. Can I please know your name?
Sneha.
Okay. So Sneha, according to Sneha, it's second and fourth option. Anybody else?
First and fourth.
First and fourth. And who is this? Can I please know your name?
Sanika.
Okay. So we have two people. Anyone else?
Ma'am, first and fourth.
Okay.
Ma'am, first and fourth option.
Okay. Anybody else would like to answer?
First and fourth.
Okay. So most of you all are correct. First options basically the pharmacokinetic studies help in determining the dosage regimen, and the fourth option that is how drugs are absorbed or metabolized throughout the body. These two options will be the correct answer. Okay. Okay. Now we'll move on to the next question. Aqueous solubility of three drugs was tested at different pH. Rank them in increasing order of solubilities at pH 6. Which of these 8 options do you all think is the correct one? I'll give you some time to go through the question and then we'll discuss. Let me know if anybody is ready to answer.
Ma'am, fifth option.
Fifth option. Okay. Anybody else? Anyone else has any other answer in their mind? You can speak up directly. Here we have three drugs that was tested at different pH, and this plot shows their aqueous solubility at these different pH, and you have to rank them in increasing order at pH 6, lowest to highest at pH 6.
Ma'am, option number fifth.
Fifth. Okay, so we have two people going for fifth option. Anybody else?
Fifth.
Fifth. Okay. What about others?
Fifth option.
Okay. Anyone else would like to answer?
Ma'am, first.
Okay. Okay. So here is the correct answer. Tetracycline, indomethacin, and chlorpromazine. So first option will be the correct answer. So if you look at the plot, we want solubilities at pH 6. If you simply create a line, so this one is the lowest, this is the second, and this is the third. So we have this tetracycline, and then we have indomethacin, and then this is for chlorpromazine. So the first option will be the correct answer. Okay. So we'll move on to the next question. Here is the third question. Particles of what size can be excreted by kidneys? There are different sizes. Which one do you think can be excreted by kidneys?
Ma'am, less than 10 nanometer.
Okay.
Option 4, ma'am.
Okay. Anybody else? Anyone else? Yes, Astha, you can speak.
Ma'am, is this assignment questions or
No,
just for
this
rehearsals?
is just for rehearsal. So, assignment questions you guys have to submit by 7th August. The due date is not over, so we can't discuss the assignment questions now. After you submit it, then only we can discuss. This is previous year assignment.
Ma'am, where can we find the assignment question?
Assignment question, if you go to the login to the portal, you can directly access it, right? NPTEL course, go to the drug delivery course, and if you click on week 1, at the end you'll find quiz 1, week 1 assignment, something like that.
Okay, ma'am. Thank you.
Okay, so yes, fourth option is the correct answer. Only less than 10 nanometer particles can be easily excreted by kidneys. If you go through the lecture, there is one particular diagram where it shows the hindrance particle phase at different levels with glycocalyx and endothelial cells and all those things. So only the 10 micron particles can easily, less than 10 micron particles, sorry, 10 nanometer particles can easily pass through and will be excreted by the kidneys. We'll move on to the next question. So here, uh, the question is an anti-tubercular drug is administered via two paths, inhalation and intravenous. The alveolar fluid from lungs was collected at different time points. So please explain the large difference in the bioavailability of the drugs for the different mode of administration. This is for the inhalation and this is for the intravenous route. Anybody would like to answer?
Ma'am, answer third.
Okay. The bioavailability of inhalation route is higher for lungs and is hence reflected from the bowel fluid. Okay. What about others?
Ma'am, answer number third.
Okay. Anyone else? Okay, both of you are correct. It will be the third option, which is the bioavailability of inhalation route is higher for lungs and is hence reflected from the bowel fluid. If you give intravenous, it is first going into systemic circulation and then some of it reaches that peak level in the lungs and then it gets cleared out further. But if you see the inhalation route, it's going maximum and then slowly getting cleared out from the lungs. So the third option will be correct. The bioavailability of inhalation route is higher for lungs and is hence reflected from the bowel fluid. Okay. We'll move on to the next question. So which of the following will have a higher partition coefficient? These are the options. Which of these do you think will have a higher partition coefficient? Anyone? So just to remind you, partition coefficient was basically the solubility of drug. Yes. So partition coefficient was basically the solubility of drug in oil by water. Two immiscible liquids where one is oil and the other one is water. Solubility in oil. And which of these options do you think will have a higher partition coefficient?
Ma'am, I don't know much about this topic. Can you explain more deeply?
Partition coefficient? Hello? Yeah, we'll discuss the answer. Let me first see.
Yes, ma'am.
Let's first see if anybody can answer and then we'll go through it after the answer is discussed.
Okay.
If anybody is writing on the chat, please can you speak up? It's difficult for me to access the chat and get back to the full screen again and again. So if you can speak up if you want to answer directly. Which of these do you think will have a higher partition coefficient? And partition coefficient is basically solubility of the drug in oil phase divided by solubility of the drug in water phase.
Ma'am, first.
Okay. Anybody else would like to answer?
Ma'am, first.
Okay. Okay. Yes,
Fourth
you.
लग रहा है.
Sorry.
It may be fourth option.
Fourth. Okay. Anyone else? Okay. So those of you answered the first option, that is correct. So as I was saying, partition coefficient is basically the solubility of the drug in oil phase in two immiscible liquids, which is in which one you can assume as oil phase and the other one water phase. So yeah, if you look at the first option, we have a lot of carbon in it, which makes it more non-polar and soluble in oil phase. So we'll have a higher value of this as compared to water, as compared to the other options as well. And that's why we'll have this one have a higher partition coefficient. And how it relates is the partition coefficient basically lets you know whether your drug will be delivered, can pass through the cell membrane or not. So higher the partition coefficient, more lipophilic it will be or more soluble in oil phase, and there will be higher membrane diffusion as compared to a water soluble drug. So that is basically the partition coefficient. Somebody was asking some doubt. I hope you are clear. It basically tells you if it can cross the membrane permeable, if it is membrane permeable or not.
Okay, ma'am.
So we have higher partition coefficient, increased membrane permeability. Similarly, lower partition coefficient, decreased membrane permeability. So like this question where the carbon chain is given, you can also be asked so based on their solubility in water. If there are different drugs given which have different solubility in water, so based on their solubility, the highest soluble in water will have the least permeability, whereas the least permeability, whereas the lowest soluble in water will have the highest permeability. So that's how you can relate with different questions. Just have to look into the drug molecule that you are working on. Okay, we'll move on to the next question. Which two statements are false for partition coefficient? These are the options. First, the ratio of the concentration of a solute in two immiscible liquids when it is in equilibrium across interface between them. Second, the higher the lipid or water partition coefficient, the greater the rate of transfer across the membrane. Third is the higher the lipid water partition coefficient, the lower the rate of transfer across the membrane. Fourth, lower the polarity of the drug, higher the lipid water partition coefficient. And fifth is higher the polarity of drug, higher the lipid water partition coefficient. So I just explained the partition coefficient thing. You guys can think about it and let me know what you think is the correct answer. Here you have to select two false statements for partition coefficient.
Ma'am, third and fifth.
Third, okay, third and fifth. What about others?
Ma'am, third and fourth.
Third and fourth, okay. Anybody else?
Third and fourth.
Third and fourth, okay. Anybody else would like to answer?
Third and fifth.
Third and fifth, okay.
I think third and fifth.
Okay. Okay, so let's see what is the correct answer is. One is the higher the lipid water partition coefficient, the lower the rate of transfer across the membrane. Third option. Higher the polarity of the drug, higher the lipid water partition coefficient. Fifth option. So those of you answered the third and fifth, that's the correct option. Here we were asked to select two false statements. So as I was discussing in the previous slide, we have partition coefficient as higher solubility in lipid or oil phase and lower solubility in water. Sorry, solubility in lipid upon solubility of water. So basically the first option is correct, the ratio of concentration of solute into immiscible liquids. The second option is the higher the lipid water partition coefficient, greater the rate of transfer, that is the overall value of higher the partition coefficient, there will be more transfer. That is the correct answer. And then the higher the lipid water partition coefficient, lower the rate of transfer. So this is contradicting the second statement. So this will be the first wrong answer or false statement. And then lower the polarity of the drug, higher the lipid water partition coefficient. So polarity of the drug is basically solubility in water. So if it is less soluble in water, low polarity of the drug, then it will be a higher lipid water partition coefficient. So basically this option is correct. And if you look at the fifth option, higher the polarity of drug, that means more value of this, higher the lipid water partition coefficient. The overall value will go down. So this is a wrong statement. So third and fifth option will be the correct answer for this question. Okay. So let's look at the next question now. Which of the following two statements are true for bioavailability? Options are, it refers to how much drug is available in shops. It can be determined by calculating area under the curve by plotting serum concentration of drug over time. It does not depend on route of administration, and it refers to the amount of drug that is lost in first pass metabolism. It does not depend on drug physicochemical properties. Bioavailability is considered 100% when drugs are administered intravenously. I'll give you some time to go through the question again and you can let me know what you think the correct answer is. Which two statements are true for bioavailability?
Second and sixth.
Okay.
सेकंड एंड सिक्स और थोड़ा सा फोर्थ में भी डाउट हो रहा है.
Fourth one. Okay. It's okay. We'll discuss the options again after we disclose the answer. But let me know what you think the answer is first. So two people, second and sixth option. Some doubt in fourth. What about others?
Ma'am, second and sixth.
Okay. Anyone else would like to answer?
Second and sixth are thinking.
Okay. Okay, let's look at the answer. So first is it can be determined by calculating the area under the curve, plotting serum concentration of drug over time, and next is bioavailability is considered 100% when drugs are administered intravenously. So second option and sixth option is the correct answer. So bioavailability is basically the amount of drug that is in systemic circulation. Okay, systemic, that is in systemic circulation. So since it is in systemic circulation, you can find the amount of drug from the serum. So if you plot the serum concentration of the drug over time, you can get the bioavailability. And also it is considered 100% when drugs are given intravenously. So it is directly going into the blood and uh, remaining in the systemic circulation. And that is why when we calculate the bioavailability of a drug, it is always the amount of drug uh, in a different route, any route basically, and over the intravenous route. And for intravenous, it is always 1. So it will be, you'll always see less than 1 bioavailability for different delivery routes such as oral or subcutaneous. All of different routes will have different bioavailability, and based on your bioavailability, if you want your drug to be in systemic circulation for it to be effective, you need to see whether you want to give it intravenously, orally, or any other route. Okay, let's see.
Ma'am, then
Yes,
can the second option can be also true?
second option. It does not, it says it does not depend, but it does depend on route of drug administration, right?
No, ma'am, the second
Second,
option.
second option is correct, yes. Can you repeat your question, please?
So,
It is saying,
no, ma'am, I just got confused in the number.
okay, okay. And yeah, somebody was asking about the fourth option. It refers to the amount of drug that is lost in the first pass metabolism. So here we are not looking at, I mean, bioavailability does not look at the amount that is lost, but basically that is remaining in the systemic circulation. But first pass metabolism decreases the amount that goes into systemic. So it does somehow affect it, but it does not really, we use that for bioavailability. Okay. Okay, I guess these were all the questions I had for this session. If anybody has any other doubt, then you can let me know or we'll meet in the next session. And for your information, this entire session was recorded and will be uploaded on YouTube. The link will be shared by the NPTEL team to you, and you can always go back and look into this session on YouTube to check what all things were discussed.
When will be the next session, ma'am?
Next week, same time.
Tuesday.
Yes,
Okay, ma'am.
Tuesday
Ma'am,
6 to 8. Yes.
will this the final exam for this be conducted in subjective form or MCQ form?
I think it's MCQ form, and some questions, numerical questions, might have like a range of answer where you have to just enter one numerical value. It will be mostly like the assignment questions that you solve over the time. Do the same thing.
Okay, ma'am.
Anyone else has any other questions? If not, we can close this session here, or if somebody has doubt, you can stay and ask me whatever your doubt is. You're feel free to leave the session if you don't want to continue now. And see you next
Thank
week.
you, ma'am.
You're welcome.
Thank you, ma'am.
Yes, of course.
Welcome. Anybody has any other doubts?
Ma'am, we got three links today for the session.
Yes.
So, I didn't understand. I didn't understood why we got those three links.
Yeah.
I
So,
connected on the first link.
okay. So we have three different TA for this particular course, drug delivery, and you'll have three different session. And there was some error, and this time all of us had selected this time slot, Tuesday 6 to 8. That's why it was clashing. From next week onwards, there will be three different sessions, and please feel free to join any of the session. But other
And
sessions will be hosted by other TAs, and the Tuesday 6 to
okay.
8 will be conducted by me.
So the material which we would be taught is going to be the same. It's just the teachers are going to be different.
Yes, also depends on the material, but more or less it will be same. We
Yeah,
are
yeah.
going to discuss the previous year assignment or concepts, those things.
Mhm.
But yeah, different
Okay.
teachers basically.
Okay. Okay. Thank you, ma'am.
Yeah. Any other doubts? I see few more people joining now. If you guys want me to start the session again, I can start. Please let me know. We discussed previous year assignment questions, and I'll just discuss those questions again for people who join now. Okay, for those who joined now, let's start the session again. Let me know if you guys can see my screen first. Is it visible to everyone? Can you please unmute and let me know if you can see my screen? Okay. So we'll start the session again for those of you joined now. So these were the topics that was discovered this week: the drug delivery, an introduction to drug delivery, pharmacokinetics, wherein first pass effect, factors affecting the pharmacokinetics, all those things were discussed. And then pro drugs, introduction to polymers, different types, natural, synthetic, their synthesis, step reaction, chain reaction, and their properties, their molecular weight, their glass transition temperature, crystallinity, all those things were discussed in these last two topics. So I'll go through the previous year assignment questions again. This was the first question. Which two statements are true for pharmacokinetics? And these are the options. This is not the current assignment. This is a previous year assignment that we are discussing to help you in understanding the concepts. Okay, so these two are the correct options. It helps in determining the dosage regimen, and it studies how the drugs are absorbed or metabolized throughout the body. So basically the first option and the fourth option. Okay, I think the answer is already showing here, but this was the next question. Aqueous solubility of three drugs was tested at different pH. Rank them in increasing order of solubilities at pH 6. So for this is a plot for the solubility of the drug at different pH, and you are asked to rank them in increasing order. So if you look at pH 6, tetracycline has the lowest, and then we have indomethacin, and then we have chlorpromazine at top. So this will be the increasing order of solubilities. First tetracycline, then indomethacin, and then chlorpromazine. Okay, please feel free to stop me if you have any doubts or any questions when I'm explaining. This was the next question. Particles of what size can be excreted by kidneys? So here the correct answer would be less than 10 nanometers. So more than 10 nanometers will be stopped by there are different cells and basically features of the kidney like glycocalyx, the endothelial cells. There are different barriers, and based on those barriers, particle size more than 10 nanometers can be prevented by kidney excretion, but less than 10 nanometers can be easily excreted by kidneys. Okay, so here is the next question. An anti-tubercular drug is administered via two paths, inhalation and IV route. The alveolar fluid from lungs was collected at different time points. Please explain the large difference in the bioavailability of drugs for the different mode of administration. So this is the plot and these are the options. Feel free to go through the question and let me know if you want to answer first, and then I'll discuss the answer. You can unmute yourself and answer. Which of these options do you think is the correct one? I hope I'm audible to everyone. Can someone confirm?
Yes, ma'am.
Okay, thanks. Yes, please go through the question and let me know what you think the answer is, and then I'll discuss the answer again. Anyone? Okay. So the correct answer is the third option. The bioavailability of inhalation route is higher for lungs and is hence reflected from the bile fluid. So here we have two different plots. One is for the inhalation. So as you can see, the drug has a higher value and then it's slowly decreasing for the inhalation route. And then we have for intravenous that increases and after some point it decreases. So basically, and this plot reveals the concentration of the drug from the lungs. So if you are injecting intravenous after systemic circulation, at some point, some part of the drug is reaching the lungs, and then from there it is getting cleared. But via inhalation route, most of them are reaching the lungs and then they are getting cleared. So since inhalation is directly going to the lungs, the bioavailability of the drug via this route will be higher for lungs and is hence reflected by this plot. Okay. Here is the next question. I have already disclosed the answer here. Which of the following will have a higher partition coefficient? So the partition coefficient basically tells you about the solubility of drug in oil or lipid phase divided by solubility of the drug in water phase. And higher the higher the partition coefficient, more it is membrane permeable. Lower the partition coefficient, less it is membrane permeable. If you look at the options here, the first option has more carbon chains or a longer carbon chain, more carbon groups. That means it will be more soluble in oil phase or lipid phase. So that will be meaning higher partition coefficient. So this will have the higher partition coefficient and hence the correct answer. Please feel free to stop me any point you want. So here in this question, it is asking for two statements which are false for partition coefficient. Just now I discussed partition coefficient is basically solubility of drug in the lipid phase by the water phase. So if we go through the options, the first option is the ratio of concentration of a solute in two immiscible liquids when it is in equilibrium across the interface between them, which is basically this. So this is the correct option. Next, the higher the lipid water partition coefficient, the greater the rate of transfer across the membrane, which is what I explained in the previous slide. So this option is also correct. But if you look at the third option, the higher the lipid water partition coefficient, the lower the rate of transfer across the membrane. This is the wrong answer. So this will be our first false statement. And then lower the polarity of drug, higher the lipid water partition coefficient. So polarity of the drug basically meaning how soluble it is in water. So if lower polarity of drug, that is if this value is less, then this value will automatically go up. So that is the correct option. And now if you look at the last option, higher the polarity of the drug, higher the lipid water partition coefficient. So basically if this value is high, then this is also going high. No. If this value is high, this will automatically go low. So this option 3 and option 5 will be the correct answer here. These two are false statements for partition coefficient. This was the next question. Which of the following two statements are true for bioavailability? Options are it refers to how much drug is available in shops. No. Second option was it can be determined by calculating area under the curve by plotting serum concentration of drug over time. Yes, this will be a correct option. So bioavailability is basically determines the concentration of drug or the amount of drug that reaches into the systemic circulation. And if you get the serum concentration of drug over time, you can determine the bioavailability of that drug. Third option is does not depend on route of administration. This option is wrong. It does depend on the route of administration. So if you look at the bioavailability formula, it is basically the amount of drug that is available from any other route upon amount of drug available in systemic circulation when given intravenously. So it does depend on the route of drug administration. Next option is it refers to the amount of drug that is lost in first pass metabolism. So this is basically what amount is lost, not how much is available in the systemic circulation. So this is also not true. And then fifth option, it does not depend on drug physicochemical properties. Yes, it does not depend. And then the bioavailability is considered 100% when drugs are administered intravenously. Yes, so as I was saying, the bioavailability is drug via any other route upon the drug amount in systemic circulation when given intravenously. So when given intravenously, this will be also intravenous. So both of these value will be 1 and your bioavailability will be 100%. But if you give any other route, this value will be slightly lower and the value will be less than 1. So the correct option here will be option 2. It can be determined by calculating area under the curve by plotting serum concentration of drug over time. And sixth option, the bioavailability is considered 100% when drugs are administered intravenously. Yes, so these were all the questions from the previous year assignments. If you had any doubts in any of these questions or any of the topics covered this week, please let me know.
Excuse me, ma'am.
Yes.
Ma'am, I joined the meeting a bit late. Will these questions be available in the app so that we can download and refer it?
uh, Not the app, but these questions. So this entire session was recorded, and it will be uploaded on YouTube. So you can always, and the link will be shared with you all. So you can always go through the YouTube session to look at the answers. Also, the slide that I'm presenting today, this will be also shared with you. So you can always go back to the slide or the YouTube video to go through the questions.
Okay, ma'am.
Any other doubts? Anyone has any other doubts in these topics or the questions I discussed so far? Okay, so for people who joined right now, we have already discussed some previous year assignment questions and few topics. If you want me to go through the questions again, let me know. Or if you have any other doubts in the topics that was covered for this week, then also we can discuss. Please let me know if you want me to start the session again. with the questions or if you have any other doubts. Okay. I'll discuss the questions. Maybe we'll wait for another minute because I still see some people joining. But till then, if anybody has any other doubt, please let me know. Okay, so for people who joined earlier, I've already discussed these questions. I'm going to discuss the questions again for the new people. If you want, you feel free to leave, and I'll start the question and answers again. These questions are from the previous year assignments, and just to help you understand the concepts better. I hope I'm still audible to everyone. Let me know, and then I'll start.
Yes, ma'am, you are audible.
Okay. So this was the first question. Which two statements are true for pharmacokinetics? So here, the first option, that is pharmacokinetic studies help in determining the dosage regimen. This is the correct one. Pharmacokinetic helps us understand the drug receptor interaction at the tissue level. No, this is pharmacodynamics. And then pharmacokinetic studies are used to identify new drug targets. No, pharmacokinetic studies how drugs are absorbed or metabolized throughout the body. Yes. And then pharmacokinetic studies how diseases spread in a geographical region. No. It studies the mutations in gene responsible for diseases. That's also incorrect. And then it studies how drug dissolves in water and diffuses in air. That is also wrong. So the first option and the fourth option, these two are the correct answer for this. It helps in determining the dosage regimens, and it studies how drugs are absorbed or metabolized throughout the body. This was the next question we discussed today. Aqueous solubility of three drugs was tested at different pH. You have to rank them in increasing order of solubilities at pH. So this plot here is basically at different pH. It is giving the aqueous solubility of three different drugs: indomethacin, tetracycline, and chlorpromazine. Uh, Yui Hirasawa. Okay, the TGTC curve. I'll try to explain after I go through these questions again. Okay, so for this question, if you look at, this is the aqueous solubility, the y-axis. So if you look at the plot at pH 6, tetracycline has the lowest aqueous solubility, and then we have indomethacin, and at the top we have chlorpromazine. So this will be the increasing order of solubilities at pH 6. This was the next question. Particles of what size can be excreted by kidneys? These are the options. I'll wait for you guys to answer. What do you think is the correct option here? Particles of what size can be excreted by kidneys?
It's less than 10 nanometer.
Okay. What about others?
Yes, ma'am. Option 4.
Okay. Anyone else?
Option 1, 1 to 100 microns.
Okay. Anybody else? Anybody else would like to answer? Here the
No one
correct.
else.
Yes. Sorry. Can you please repeat your answer?
No, ma'am, no, ma'am.
It's okay. I'll discuss the answer anyways. Just let me know what you think the correct answer is.
Actually, ma'am, I want to say that no one else is answering.
I see. Okay.
Okay.
Okay. Okay. So the correct answer would be less than 100 nanometers, not microns, because these are too big to pass through all the barriers that are there in when during the excretion of the kidneys. There is glycocalyx, the endothelial cell barriers between the cells, all those things are there. So less than 10 nanometers can easily pass through this and can be excreted by kidneys, but size more than 10 nanometers cannot be excreted. So fourth option will be the correct answer. Here's the next question. An anti-tubercular drug is administered via two paths, inhalation and intravenous, and the alveolar fluid from lungs was collected at different time points. And you have to explain the large difference in the bioavailability of the drug for the different mode of administration. This first one is the inhalation route, and this is the intravenous route. As you can see, it has very low bioavailability at the lungs, and this has very high bioavailability. Why is that? These are the options. Can you let me know what do you think the correct answer is?
Ma'am, inhalation will directly reach, the drugs will be directly reached to the lungs, whereas intravenous, it takes a lot of time to reach the lungs, and there will be like it should pass through from tissue to blood vessel, then it adds to move through the blood to the lungs. So there will be some losses. Whereas in inhalation, it directly passes to the lungs.
Yes, you are absolutely correct. So what do you think the correct option will be here?
Ma'am, aren't we going to use the first pass principle for this?
No. So here it is talking about the bioavailability of drug at the lungs. So we are just measuring what amount of
Yes, ma'am.
drug
Sorry,
is
ma'am.
available in the lungs. Yes, so what is the
So
correct answer?
option 3 will be correct.
Oh,
Option 3.
okay.
Yes, ma'am. Option 3.
Oh, yes, you both are correct. It will be the bioavailability of inhalation route is higher for lungs and is hence reflected from the bowel fluid. So I think she already explained. If you go deliver via inhalation route, a maximum amount of drug is reaching to the lungs and then it is slowly getting cleared over a period of time. But if you talk about intravenous route, initially there is very less concentration or no concentration of drug in the lungs, but as it reaches from the systemic circulation passing through various barriers to the lungs and delivered in the lungs, there is a peak after some time and then it is further getting cleared from that space. So we have very less bioavailability of the drug in the lungs when delivered via inhalation route, sorry, intravenous route as compared to the inhalation route. Okay. The answer is already given here. Which of the following will have a higher partition coefficient? Can anyone explain why do you think this is the correct answer? Anyone? The answer is already given. Can you please let me know why do you think the answer is correct answer?
Ma'am, is it like related to the molecular weight and the bulkier group? So, higher the molecular weight or the bulkier group, lower is its solubility in the solvent. So, the partition coefficient will be high.
Almost there. Think a little bit about the molecule itself. What is there in the molecule that is determining its partition coefficient?
As the molecule is organic molecule, it will be less soluble in the water and more soluble in the organic solvent. So the solubility in the water will be low, therefore the partition coefficient will be high.
Yes, yes, you are absolutely correct. So, as you can see, as compared to the other options, here we have more carbon groups, meaning less soluble in water and more soluble in the lipid phase or the oil phase, so it will have higher partition coefficient. And for those who don't know this concept already, so partition coefficient basically talks about the solubility of the drug in the oil phase or lipid phase by solubility of the drug in water phase or aqueous phase. And higher the partition coefficient, more it is able to cross the membrane permeability. So that is partition coefficient. And in this question, this will be more soluble in the oil phase, so it will have higher partition coefficient and it can easily transfer across the membrane as compared to the other molecules. Here we have the next question. Again, you have to select two statements that are false for the partition coefficient. So I already talked about this partition coefficient in the previous slide. So it basically talks about the ratio of the concentrations of a solute into immiscible liquids, which is in this case oil and water, when it is in equilibrium across the interface between them. This next question is, the higher the lipid water partition coefficient, the greater the rate of transfer across the membrane. This is what I talked about in the previous slide. Again, third option says the higher lipid water partition coefficient, the lower the rate of transfer across the membrane. This will be wrong, because a higher partition coefficient means the rate of transfer across the membrane is more. Then fourth option is lower polarity of the drug, higher the lipid water partition coefficient. So lower polarity of the drug, meaning its solubility in water is less. If this is less, this value goes up. So higher lipid water partition coefficient. So this option is correct. And then we have fifth option, higher the polarity of the drug, higher the lipid water partition coefficient. If the polarity of the drug is high, then it is more soluble in water. So this value will automatically go down. So instead of higher, it should be lower lipid water partition coefficient. So this option is also false. So option 3 and 4 are false for partition coefficient, and hence the correct option for this question. Here's the next question. Which of the following two statements are true for bioavailability? Which of these options do you think is the correct answer? Can anyone answer which of these options do you think is the correct one?
The last option.
Last option, okay. And another one, there are two statements that are correct here.
Second option as well.
Okay,
Second and six.
okay. Anybody else would like to answer? Yes, you all are correct. It will be second option. That is, it can be determined by calculating area under the curve by plotting serum concentration of drug over time. So bioavailability is the amount of drug available in the systemic circulation. Since it is in systemic circulation, if you collect the blood and get the serum concentration of the drug over time, you can plot it and you can get the bioavailability of the drug. So that is how you can determine. And the next question is, bioavailability is considered 100% when drugs are administered intravenously. So how we get the bioavailability is, we calculate the amount of drug available in systemic circulation when delivered via any route upon when it is delivered via intravenous. So if you are delivering via intravenous, both the values will be same. So it is like 100% drugs are bioavailable when administered intravenously. But as you change the route, these value will change and you'll get lesser and lesser value than 100% for other routes. So Option 2 and option 6 is the correct answer here. Okay. Yeah, this is all the question we discussed so far. If anybody has any doubt in any of the question we discussed or any topic, let me know. I think someone asked about the transition temperatures. I'll explain that once. If anybody has any other doubt, then let me know. Kindly speak up because it's difficult to come here and check the chat and then go back again. Yeah, somebody was
Ma'am, I'm
asked.
sorry to interrupt.
Yes.
But this is not regarding the curriculum as such, but the mail that I received regarding this session was all marked under 30th, like session 1, 2, and 3 for the same timing. So I'm
Mhm.
confused if there's a glitch in it, or do we have any other sessions coming ahead in this week?
Yeah, so this week you won't have any other session. There was some error on our part. So there are three different TAs for this particular course. And so you'll technically have three different sessions for each of us. And so all of us had selected this particular date and time. That is how there was a clash and you all got the same session, three different session on the same date and time. But from next week onwards, you'll have three different session and please feel free to join any session you want.
Okay, ma'am. I had just joined like 10 minutes ago because I was caught up with some other academic work. Could it be possible if you could, like, at the end of the class, quickly just run through the slides that you covered from the start?
Okay, I can run through now only. Uh, so basically, these are some previous year assignment questions that are based on the first week topics covered, and you'll face similar kind of questions in your exams as well. And but this is different from the current assignment that you have been given. So first question was asking about the pharmacokinetics, two statements that are correct. So here the first option was studies help in determining the dosage regimen. That will be the correct answer. And then it how drugs are absorbed or metabolized throughout the body. These two options will be the correct answers. Also, for your information, this entire session is recorded and will be uploaded on YouTube, and you'll be share the link will be shared with you all, so you can always go back to the session on YouTube and check the answers discussed. And the presentation that I'm
Okay, ma'am.
sharing now also, I'll share the link for this presentation as well, so you can always go back to the presentation if you want. Okay, so
Sure.
in this question, the aqueous solubility of three drugs was tested at different pH, and so you have different curves for three different drugs for their aqueous solubility, and it is asking for the increasing order of solubilities at pH 6. So if you look at pH 6, we have lowest solubility of tetracycline, and then we have indomethacin, and then chlorpromazine. So the first option will be the correct answer. Next question was particle of what size can be excreted by kidneys? So this is straight away information from the lectures itself, less than 10 nanometers. If you go above this uh, size, uh, it will be prevented from excretion by kidneys. This was the fourth question, where anti-tubercular drug was administered via two different route, inhalation and intravenous. And after the alveolar fluid from the lungs was collected, this plot shows the bioavailability of the drug for different mode of administration. So if you look at here, this is the inhalation route and this is the intravenous route. So if you see the inhalation route, inhalation is directly from the, after you inhale the drug, it is reaching the lungs. So you have a greater amount of drug at the lungs in the beginning, and then it is slowly getting cleared. And this is opposed to the intravenous route where you get the drug by intravenous and it's in systemic circulation, and then it comes to lungs where there is an increase in concentration of the drug, and then slowly it gets cleared from the lungs over the next time period. So here the correct answer would be the bioavailability of the inhalation route is higher for lungs and is hence reflected from the bowel fluid. Okay, so this is the next question. Which of the following will have a higher partition coefficient? So partition
Ma'am,
coef
was present.
sorry?
I was present from this questioning.
Okay, sure. So yeah, so for this question, this will be the first answer is the correct answer. First option is the correct answer, and for this false statements 3 and 5. This okay. Has anyone does anyone have any other questions? If not, I think someone asked about TG-TC curve. I'm not sure what you really want to know. So there are three different temperatures: TG, glass transition temperature; TC, which is the crystalline temperature; and TM, which is the melting temperature. So if you plot the curve, here we have temperature, and over time you'll get a plot something like this. Okay, I am not able to draw the curve properly, but what you'll get is first you'll get a TG temperature or the glass transition temperature. So when you heat the polymer, over time you'll see a transition happening here where it is going from the glassy state to a more rubbery state. And then you'll have the TC or the crystalline temperature. So after a point of time, here the crystalline TC will come where the polymer will now, so from a hard glassy state, it has become a rubbery state, and the polymer will now start to arrange itself at this point to a more ordered structure. And as you reach towards the end of the plot, you'll have TM or the melting temperature, where at this high temperature again this ordered state gets disordered and it has completely melted. So you'll have first TG, TC, and then TM.
Ma'am, what happens to the polymer after it has reached TM?
It's
What form
melted.
does it take after that?
It's melted, right? I mean,
Yes, ma'am.
you'll have different
Does it
chains,
turn
and it,
amorphous?
it's just it's just high temperature. It's they are randomly ordered, and you can't, I mean, molten state basically.
So, ma'am, once it cools down, will it turn back to being amorphous?
Yes, I think so.
Okay, ma'am. Thank you, ma'am.
But I'll have to cross check again. But yeah, depending on the polymer, it might be different, but I think it will be turning to more amorphous state
Ma'am,
at
or
this point.
will it be
But
like if we cool it at a very fast pace, then it turns into
yes,
amorphous, or if you cool it slowly, it turns into
yes,
crystalline,
it depends on the
semi-crystalline structure?
arrangement basically. So here, as I was saying, it is arranged, and here again it is disarranged. So based on whether it is more orderly state or disorderly state, it will take some other form.
Yes, ma'am. Thank you, ma'am.
Okay, anybody has any other doubt? So these were the topics that were covered this week. And based on this, we solved a previous year assignment. And this entire slide will be shared with you, the link for the slide as well as the session, because this entire session was recorded, and it will be uploaded on YouTube and you'll get the link. If you have any other doubt or any other thing to discuss, let me know, else we can close this session and meet next week.
Ma'am, regarding the final exam, it will be completely MCQ based, or do we have pen paper mode also? Is it like a mix?
Yeah, it will be mostly like the assignment problems that we are discussing, either MCQ or single value, like the numerical problems. There will be a range of acceptable answer, but you have to enter one value, kind of like that. But it won't be subjective.
Okay.
Oh, and not pen paper based. This is computer based exam. Yeah. Anybody has any other doubt?
No, ma'am.
Okay then. Okay, then we'll close this session here, and you'll soon get the links for the both the video and the presentation, and we'll meet next week. Thank you for joining.
Thank you, ma'am.
Yeah.
Thank you, ma'am.